Hi everyone. In this session, I'm going to give a API Map update of the collaborations with open source, specifically with LF Edge Akraino. And I'm the presenter, Shen, VP of Technology Strategy from Mavenir. And also I'm the technical expert from the API Map ISG. So let's first take a look at the API Map Working Group Decode. Working Group Decode has a mission to enable edge computing in industries. And specifically, it promotes the API Map specifications and APIs adoption. There are 4 pillars of Working Group Decode. They are ecosystem and collaboration, testing framework, Mac sandbox, and Mac hackathons, plug tests, and POCs. So out of these 4, the ecosystem and collaboration is foundational, and open source collaboration is a big part of it. There is a Mac ecosystem wiki owned by API Map. So the wiki will try to collect projects and implementations of Mac, and it opens to any organizations. It's a starting point to find solutions to build on, and the wiki page creates good opportunities to reach users and developers. And open source collaboration between API Map and LF Edge Akraino is one good example to showcase this collaboration. This diagram shows a landscape of Telco open source projects in Linux Foundation. From left side, the devices, to far edge RAN, near edge local edge data center, and then to central private and public cloud where core network functions are deployed. In this diagram, LF Edge is covering the edge location area. It is an umbrella organization to establish an open interoperable framework for edge computing independent of hardware, silicon, cloud, or operating systems. Akraino is a unique open source project under LF Edge. It's marked on this diagram by the red dotted line box. Akraino has 2 major categories of projects: the Blueprint project and the Feature project. The Blueprint projects focus on bringing deployable edge blueprints that are globally adopted into commercial solutions and use cases. Akraino has delivered fully functional edge solutions across industry sectors and disciplines. The Feature projects are essentially telco development projects with the source code embedded into the Akraino open source community. This diagram provides an overview of Akraino Release 5 projects distribution. Akraino recently issued its 5th release with 3 new additional blueprints to address use cases such as smart cities, cloud-native multi-tenant, and topology prediction for vehicular networks at the edge. Release 5 also includes updates to many of its existing 30+ blueprints. Akraino blueprint projects span from dedicated far edges to shared X as a service type of edges. It covers infrastructure edges as well as edge applications. New use cases combined with updated and existing blueprints provide an edge stack for industrial edge, public cloud edge interface, federated ML, and more. All of the Akraino blueprints have been tested and validated on real hardware labs supported by users and community members. The Akraino community has established a full stack automated testing with strict community standards to ensure high quality blueprints. This is an example of a blueprint project from Akraino. It's called Enterprise Applications on Lightweight 5G Telco Edge. So on this page, the left-hand side is the functional diagram of the blueprint project, and the right-hand box listed a few key items highlighting the API Map relevance of this blueprint project. The blueprint project itself is providing a lightweight telco edge platform enabling the enterprise applications on telco edge. It offers a unified portal for platform management and for app developers. The management platform design is following the reference architecture design of the API Map specification. And the blueprint complies to Mac platform management specifications MEC 011, and also it adopted the MP1 and MM3 interfaces from API Map specifications. Just as any other blueprint projects within Akraino, it has a key component project in the blueprint. And here that project is called Edge Gallery. Edge Gallery is also an open source project. The focus of the Edge Gallery is to provide a Mac platform framework at carrier's network edge. And Edge Gallery by itself also complies to Mac 010-2, Mac 11, Mac 09, and it'll continue to support additional Edge API Map APIs. This page is to highlight a use case of the previous blueprint. The demo is a smart shelf of retail enterprise as part of Robo sites. Robo stands for Remote Office Branch Office. The Robo sites usually are resource constrained, distributed, and vulnerable for data loss in case of disasters. So in order to overcome these problems, Edge Gallery-based lightweight 5G telco edge blueprint is providing a lightweight K3S cluster on remote edge sites, and the central management of several autonomous edge sites with backup and restore capabilities added in release 5. So if we look at the diagram, the central node, which is marked reflected as the API Map MECM, is communicating with several Mac hosts, and here it's deployed in the robo sites. So in this example, we called Retail Edge 1, Retail Edge 2. So technically, they all are mapped into the Mac hosts. This is another important blueprint project from Akraino, the Public Cloud Edge Interfacing, PCEI Blueprint project. It is a project family. The purpose of Public Cloud Edge Interface Blueprint family is to specify a set of open APIs for enabling interworking between multiple functional entities or domains that provide services needed for implementation of edge capabilities, and applications that require close integration between the mobile edge, the public cloud core and edge, as well as the third-party provided edge functions. As public cloud service providers and third-party edge compute application providers deploy edge instances to better serve their end users and applications, telco mobile network operators' edge deployments offer many opportunities for collaboration by exposing their network capabilities to provide value-added services. The high-level architecture view of PCEI is shown on this page. So this blueprint will bring a new enabler layer as PCEI between the mobile telco network and the public cloud, as well as the third-party MEC platforms at the edge. The PCEI enabler layer is responsible for a few things, such as API gateway management listed here. In the southbound direction, PCI to MNO, this layer will encapsulate the core network capabilities interwork with BSS OSS management system from telco operators. Depending on the business model, this layer may be deployed as part of the MNO functions, MNO edge hardware resources. The PCEI enabler may also be deployed by a neutral operator, for example, a data center and interconnection provider, in highly interconnected and distributed locations where the public clouds, the third-party MEC providers, as well as many other ecosystem partners meet and exchange traffic and data. In the northbound direction, PCEI to public cloud and third-party MEC providers, it exposes RESTful APIs and SDKs to be called and integrated by the edge service application providers. It's supposed to be developer friendly APIs. This page is to highlight the collaboration between open source projects and standards development organizations. Here the example is the Akraino PCI Blueprint project and its component open source projects at the bottom. PCI directly interact with SCMAC, GSMA OPG, MEF, and indirectly adopt 3GPP specifications and APIs. The collaboration between ETSI MEC and the PCI, it provides a very smooth, direct communication channel between the developers in the open source community and standards experts in SCMAC. This page shows a typical Akraino TSC Technical Steering Committee priorities for Release 5. In general, Akraino offers a wide range of edge computing use case blueprints, including connected vehicles, AR/VR, security, telemetry, and telecom applications. So for Release 5, TSC issued 3 priorities. They are ORAN specifications focus, the public cloud edge interfacing focus, and also the standardization of the edge APIs. So out of these 3 priorities, the right-hand side in red dotted box is the focus on APIs of blueprint projects in Akraino. So increasingly, there is a need to gather recommendations from the community edge computing API best practices, which ones to use and when, and the format of the APIs, definition specifications. So besides fostering standardization, the API priority objective is to improve ease of use and documentation, not to pick winners. Under the TSC priority guidance, the API subcommittee started this API portal. The diversity of Akraino blueprints represent a goldmine of data describing edge computing API usage for a variety of open source platforms and services. To organize and gain insight into this data, the Akraino API subcommittee created an API information form which every blueprint must update prior to release. The API info form has mandatory sections for APIs offered and consumed, both upstream and downstream, and optional sections for Kubernetes APIs and Telco network APIs. One of the more informative and insightful results from this data gathering is the Akraino API Map shown in the next two slides. Those are which is maintained. The API map is maintained on the Akraino API portal. So the Akraino API portal link is shown here on this slide. It's publicly accessible, and it does provide cross-reference with other relevant API information sites, including the Etsy Mac APIs and other standardization APIs. The API portal also includes white papers and other API-related information. This slide is from the cloud interfacing at the Telco 5G Edge white paper from Akraino. It introduced the concept of an enabler layer to facilitate the rapid and smooth cooperation between telco networks and hyperscalers. Akraino and Etsy Mac are promoting the enabler layer approach with an application enabler facing edge end user applications and an edge enabler facing telco core networks. In this way, each side can feel confident in a reliable long-term framework in which to invest time and effort, adjusting their development pace and the resources as needed. Using this architecture, telcos can abstract implementation details of their APIs and microservices, whether they run on private data centers, public clouds, or a hybrid combination clouds, transparently to hyperscalers. Also, this architecture provides a flexible management and orchestration layer, allowing a variety of open sources to be used, such as MCO, Kubernetes, SCMano, Sonata, etc. As mentioned, a useful result generated by the Akraino API subcommittee's data gathering effort is the Akraino API Map. So shown on this page, the left-hand side is the sample snapshot of Akraino API Map, and the right-hand side is a short form list of Etsy Mac APIs, and this is provided by Etsy Mac Decode working group. Currently, the API map is hierarchical, organized with MEC and IoT branches at the top level, and telco and hyperscaler Mac sub-branches. The map is searchable. For example, you can enter radio, IoT, or Mac to find blueprints applicable to your use cases. Or you can use Kubernetes, EdgeX, or Openness to find APIs belong to specific open source communities related to your application. One of the expected outcomes of the Akraino Etsy Mac collaboration effort is an updated API map allowing more granular display and search of Etsy Mac APIs, and correlation of those with APIs consumed by Akraino blueprints. Etsy Mac APIs offer a high degree of flexibility and detail, but tend to be complex. Thus, they can benefit from use case like blueprints from Akraino level search offered by the Akraino API Map. This concludes my session, and thanks for watching.